Anyway, I'm going to be talking about the power of collaboration creating project success. So I first have a question. How many people here have used a ladder? Everybody. Everybody in this room has used a ladder. Okay, so I'm going to give you some collaborative examples just to kick this off before I dive in too deeply. I want to kick off some collaborative uses of ladders just to set the stage for what I'm going to be talking about. So this first one, now, you know, these guys, they've got a short little ladder here and not quite enough height to it, so you get one big strong guy and presto, you don't need scaffolding, right? Who needs scaffolding when you have guys like that? Here's another one. You've got a piece of equipment, but the bucket doesn't raise high enough. Put a ladder in it, get this dude up on top, and presto, you fix your chimney. That's collaboration. Another one. Now this is a good one because you've got two ladders. You've got this thing going all the way up and then a small one strapped to it and a guy changing a light bulb. And then for collaboration, you've got a supervisor down here thinking, man, I'm glad I'm not up there. Glad it's him and not me. And then here's a really genius one. Who said you have to put the legs of the ladder down on the floor? Turn it over. Put a 2x12 up here. Just make sure you follow Archimedes' law because it never fails. Otherwise, you're on the ground. But those guys have got it figured out. And then the fact is that ladders might be the reason that women live longer than men. And guys, if you ever do this, if you ever put a ladder on top of 3 tables, don't stand way over on the left side of the ladder because you're guaranteed to come down. This might be the last time that guy was ever seen alive. It's very possible. And the only good news there is it doesn't hurt until you hit the ground. So, until you hit the ground, you're fine. So that's collaboration in action. Now, speaking of ground, I want to ground this presentation and talk about why collaboration matters. So the outline of the next 20 minutes, I'll discuss why collaboration is so critical to project success. I'll give some case studies, good and bad, and then discuss a little further about PRO, how it will help the industry. I hope most of you, maybe all of you, were at the luncheon today, where we had some great speakers, Dan Baker, Jeff Coleman, and following me, by the way, is Charlie Thornton, one of the most renowned structural engineers on the planet. So we have some great opportunities for learning lined up for you here today. To set the stage, why did we form PRO? I showed this slide this morning. I'll show it again, and I've added one thing to it. This appeared just a couple of weeks ago, October 12th, in Construction Dive. It's a daily news feed for contractors. Construction lost as much as $40 billion on poor productivity in 2022. And about half of the contractors surveyed say they see it getting worse, although they did see some relief with lean practices. And no question, lean construction principles are effective. But they interviewed a guy by the name of Keon Zandy, who I don't know, but he summed it all up down here at the bottom, where he said he's a lean construction proponent. He said the real solution lies in people and how they work together, collaborating and connecting early. So when you get all of the people involved in a project collaborating and talking and sharing information early in the process, one of the comments I made at the luncheon today was that for traditional design, bid, build, if you could just negotiate the contract with the construction team, negotiate the contracts, at the same time you negotiate the design team, bring the construction team into the design, just think of the massive amounts of money we could save on projects. Massive amounts of money. It's a win-win all the way around because the contractors get paid more. They get paid for their pre-construction service. Everybody benefits. You build teamwork right out of the gate. You finish the project shaking hands instead of calling your attorneys. So, and he summed it up very nicely. Collaborating and connecting early in the pre-construction process. Very powerful statement. But why do we not get sought out more often for our opinions? Why is that so seldom properly executed? Well, because opinions are sometimes not welcome here. And we all know that from personal experience. This poor little guy here would love to offer his opinion, but that dude just won't let him. He says, no way. I'm going to muzzle you. I know what I'm doing. I know what I'm doing. I don't need your input. So oftentimes our opinions are not welcome, and consequently we do a lot of things in a silo. We work behind closed doors. We finish our work. We send it off to the next guy, and he does his thing, and we create friction points along the way. And if we can reduce friction points, we can create more efficiency and improve productivity. So now I want to go through a couple of case studies. I want to talk first about a very bad example of collaboration, a complete and colossal collaboration meltdown, and then I'll get into a good example of collaboration, which is a project I'm working on right now. But the first one you probably have heard of, most of you. This was the Harmon Tower in Las Vegas. So this was designed to be a 49-story building. So here's the Harmon Tower. This was a joint venture of MGM and Dubai World. Dubai World is the investment arm of the government of Dubai. So Dubai's investment arm teamed with MGM in Las Vegas, and they built about, I think about 7 buildings. All of this was part of the city center development. This was their flagship building, right on the corner of the Las Vegas Strip, which is here, and then Harmon Avenue directly to the north. So the southwest corner of Harmon and the Las Vegas Strip was to have been the Harmon Tower. And I got involved as one of the experts working for MGM when it went into litigation, because what happened was the building got up to the 28th floor, as high as it ever went, and there were quite a number of defects and problems being observed that should have been observed long before, but for whatever reason they weren't. And long story short, Clark County, the permitting authorities, shut construction down, stopped construction. The building went into litigation, and 4 years later, a settlement occurred, and then it was demolished in 2015. And the story behind the Harmon Tower is a massive meltdown of cooperation, collaboration, finger pointing. We had access to all the emails that were exchanged during construction. F-bombs, 4-letter words, every third word in the email. People were literally throwing punches, almost. In some cases, maybe they were in actuality, but the teamwork was zero. The level of collaboration and teamwork it was non-existent. The design was done in a vacuum and issued to the general contractor, who did his best to try to build it. And there was guilt all the way around. The settlement was just sort of, let's come to a draw and finish this thing. There was guilt on the design side, the construction side. But let me show you an example of what we had access to when we did our legal investigative work on behalf of MGM. So this is straight out of the structural design documents. So on the left, what you see is a link beam schedule. So link beams are the beams that connect components of shear walls. So if you have a shear wall with a door opening through it, which virtually every core has to access the elevators, the stairs, the trash room, and so forth, over the top of that opening you have a beam. And that beam plays a very critical role because it ties these two pieces of wall together and forces them to act as one. What you're trying to do with a core is force all of these independent pieces of wall to act as one big long wall. So the beams are very highly stressed, they're very critical, and if you looked at the straight out of the structural construction documents, you had this schedule, you had this elevation, typical elevation, top bars, bottom bars, stirrups, and down here a section. 2 top bars, 2 bottom bars, and a stirrup. Real simple. And you just take this data, you plug it into that, and go out and build your beam. So if you take some of that data and plug it in, here's what you get. It's impossible to build. This beam was literally impossible to build because they had 8 top bars, 8 bottom bars, 4 stirrup legs, the perimeter stirrup plus these 2. You've got the ears up here on the stirrups, of course, too, that get in the way. The out to out on the stirrup is 9 inches. So from this face to this face is 9 inches because you're 1.5 inches. It's a 12-inch wall, by the way, 12-inch wall. So you're 9 inches out to out, and then you have to get all these horizontal bars through the shear wall vertical bars beyond. So you have about 6 inches right here. You've got to get all that through there. It was impossible. We laid this out this was one of hundreds of link beams that we drew up, just trying to understand what had gone wrong here in the field. Now, in the normal course of events, if the drawings had been done this way and they were issued and the contractor couldn't build the beams, you'd have an RFI, you'd have a discussion, you'd have some job site meetings, and you'd fix it. You'd fix it. It shouldn't have been issued that way by the structural engineer, but it was. It could have been fixed before it was built, but the communication had dropped to zero. The architect was fighting the engineer was fighting the contractor was fighting everybody else. It was just a fist fight, and the contractor was determined to make schedule. So what he did was he would install as much rebar as he could fit, and the rest he'd just leave it out. That's how they built the building. And there, we opened up the collective experts. There were four or five structural expert firms, and we opened up 2,800 areas in the building. And of the 2,800 we opened up, fully 1,800 of the 2,800 were grossly deficient. So we would tell the field people to open up a column so we could see the rebar. We would tell them to open up a beam so we could see the link beam steel. We'd have them open up a slab area so we could see that. And about 2/3 of everything we looked at was grossly deficient. And you couldn't really put the finger on any one person, as I say, because if you can't build what's drawn, and the guy building it can't talk to the guy who designed it, because there is no communication, what do you do? Now, contractors should not have just left steel out. What should have happened in hindsight, stop the job, just stop the job. Go back to the owner and find a way to get started and do it over and do it right. But in any event, this is an example of what happens when you don't cooperate, you don't talk, you don't collaborate, and it can happen on massive projects. I think the collective damages on the Harmon Tower was something like $1 billion between the legal fees and the expert fees and the demolition costs. It was just a tragedy. Now I want to go to a good example, what I think is a good example. This happens to be one of our projects in my office right now, and just to set the stage, it's called The Bellevue because it's in Bellevue, Washington, about a mile from my office, a little less than that. And what it is, 3 towers. There's a 5-star hotel over here. Actually, 5-star hotel, 2/3 of the way up, and then residential. 2 other residential buildings over the top of a retail podium, over the top of 6 stories of subterranean parking. Here's a shot of what it will look like. It's a very, very high-end retail space. One of the most successful malls on the West Coast happens to be right over here, and they want that to be contiguous and joined at the hip, essentially, to this new building. And so it's all being driven by the opulence of the retail and the buildings above, and the structure took a back seat, at least initially. Here's another picture of it. This shows a view from the Bellevue City Park looking to the northeast. And here's a cross section. You can see the 2 of the 3 towers and the retail, 3 stories of retail here, actually 4 stories, and then 6 levels of subterranean parking. And the challenge structurally is, as anybody who's worked on almost anything knows, is that the columns in the tower may or may not align with columns in the retail, which probably don't align with columns in the parking. So you got to find a way to get the columns from here down to there and minimize the amount of transfer. That's the goal. That's the goal. So you've got to get the tower columns down through the retail, down through the lobbies, down through the parking, and get them into a foundation without too many transfer beams. A little more background information on what this project is about. You can see this very dramatic sort of skylight wing. The architect on this project is out of New York City. I won't mention their name, but they're a very well-known, high-end global architectural firm. And they've done some beautiful, beautiful, beautiful work. So they want a great big skylight, and then we have this retail and parking below. There are 2 of the towers beyond. And a shot of what it will look like on the interior when it's done. You can see the skylight above there. A lot of dramatic stairways and things of that nature. that are easier to draw than they are to build. I'm quite certain of that. Now, diving into some of the detail. If we look at the typical parking plate, we have 6 of these, and you can see that it's unusual in the fact that it's one-way angled parking throughout. So the owner of this building, who owns a neighboring shopping center, is really, really adamant that this be user-friendly parking. Minimal columns. So we have 52-foot spans across the parking modules, columns at normally 30 feet on center north-south, and we need to preserve that throughout the entire parking plate for all 6 levels. So it will park just like you're driving into Safeway. Instead of having columns at the rear bumpers, which we would like to do, we're spanning 52 feet. What that looks like in a blow-up is right here. So this is the typical parking grid. So we're 52 feet centered center on the overall module. We interlock the stalls. And by interlocking the stalls and going at about a 70-degree angled layout, we can make 52 feet work with one-way traffic. Very, very user-friendly. Very comfortable to park in, 30 feet in the north-south direction. So that's what we have to hit with all the columns that come from the towers down through the retail. We have to transfer into that parking grid. And initially, we started out with 2 ideas structurally. We said, all right, let's take all of our tower columns down. We'll put a big transfer floor in up here. We'll transfer off into a grid that works, and then down we go. Down through the retail, into the parking. That was our initial thought. This is one of 2 options we looked at initially. So a great big transfer floor, transfer off into the parking grid, and then down we go. The other option we looked at was slant columns. So we bring columns from the tower down into the retail, and then we tip them 1 floor, 2 floors. We actually tip some of these 3 or 4 floors, depending on the angle. We just find a column. So we look at a column, and we look at the nearest column down here, and we start slanting over to hit it. Real basic. You just have to be very careful of all the thrust forces that develop, because you get thrust forces going in different directions that have to be very carefully reviewed and analyzed. And what we ended up with was a combination of the 2. And this was a total mess. This was really a mess. This is where we were in conceptual design. So we had some slant columns. We had some transfer beams that you don't see very clearly, but they're up underneath this floor. This floor. We also had some transfer beams down here. So we had slant columns. We had some trusses. We had a few more trusses over here. We had slant columns in here. It was just a mess, and it priced out very high, because we took the drawings through conceptual design, partway into schematic. We sent it off to the general contractor. They priced it up, and the owner had sticker shock to the tune of about $200 million sticker shock. It was over $1 billion when it was initially priced. So we stopped and we said, look, why don't we all sit down and let's start with the towers. Let's minimize the number of columns in the towers. Let's let the structural control the layout and just see if we can make the architecture work. So let's go up into the towers. Let's minimize the column count in the towers, because the fewer columns we start with, the fewer transfers we have as we drop down through. Let's lay it out to optimize the structural floor plate, and then let the architect play with it and see if the units still work. And we did that, and this is what we ended up with. So this was the original floor plate, and we had 20 columns per tower, 60 columns total. And this was developed by placing columns exactly where the architect wanted them. So he laid out all the units, optimized the unit layout, and then we found locations for columns. We also had 2 outriggers off our core. We've used these quite commonly. If we have too long a span from the core to our column, we'll build an outrigger beam with the floor plate, so it's poured with the floor slab, and we tie that, it's just a cantilever beam basically off the core, and we tie that beam steel back into the core wall with threaded inserts. So when the core wall is poured, we have threaded inserts in the wall. You come along to pour the floor, you thread some steel into the inserts, put a beam form in, and now we have this little wing off the core that lets us span from the end of that beam out to here instead of from here to the core wall. So we shorten the span and we eliminate some column. But suffice it to say that was a very complicated floor plan on the left. That was the original scheme. What we ended up with after we optimized the floor plate structurally was 12 columns instead of 20, no outrigger beams, and 8 transfers instead of 14 for each of the towers at the podium. So we eliminated 6 transfer conditions for each tower. So 18 transfer conditions were eliminated. The price dropped significantly. And the architect at the end of the day said, you know what, I like this because the units work great. And now I no longer have columns adjacent. He was really hung up on these columns in the corners that he chose, initially at least. They weren't terribly excited about these columns right up against the perimeter of the building. So at the end of the day, everybody was happy. This was a win-win solution. And you can see the columns fall into locations that work with the architecture. They work fine with the architecture. They had to do some rework of the unit layouts. But the end result was everybody won. The architect is happy. The owner is thrilled. The structure is actually more efficient on the right than it is on the left because we have cantilevers of 10 to 12 feet around the perimeter. And cantilevers are very beneficial for the floor slab. So we have a more efficient structure. We have elimination of transfer beams. We have a happy architect and a very, very happy owner. So that was an example of the collaboration process. And just a few more slides here, Phil. I'm almost done. You can see now how clean this is. This is one of our current models. And all of the tower columns just drop straight on down. Straight on down. That's one vantage point. Here's another. All the columns drop straight on down through the retail podium into the garage. And here's the final one. And this shows what we're doing. We're eliminating all post-tensioning at these levels in the concrete tower. So we're adding some drop heads. So this is mild rebar here and here and here. And then we go to post-tensioning up there, all the way up the tower. And the infill is all structural steel. And then the garage is cast-in-place concrete. So that's an example of how the collaboration process can work and should work, and the fact that you can have happy people all the way around when you execute it properly. So the goal is, or the motto is, I should say, the takeaway is, teamwork divides the task and multiplies the success. When you can create teamwork, under all the people in under one roof, sitting around a table, working in a spirit of cooperation and trust, where they trust each other, you can create magic. So, thank you very much.